In this course, you learned a lot about React. You learned about all those core features that make up React, and you are able to build your own React apps if you went through that course. But in this entire course, we used React with JavaScript, with the JavaScript programming language. Because React is a JavaScript library, and most examples and demos and the official documentation which you find out there is about React with JavaScript. But you actually can also use React with TypeScript, and that's what this course section is about. Now, for that, I'll first of all explain what exactly TypeScript is and why we might want to use it. Good news is that it's not a totally new programming language. Instead, it builds up on JavaScript. Then I'll walk you through some TypeScript fundamentals, some important basics which you need to know about TypeScript in order to use it. And then, of course, most importantly in this section, I will show you how you can use TypeScript in combination with React, how you can write your React code with TypeScript. So, what is TypeScript and why would you use it? TypeScript is a so-called superset to JavaScript. It's a programming language which builds up on JavaScript. It extends JavaScript, you could say. And that is really important. The core programming language still is JavaScript. So the base JavaScript syntax, you know, how you write JavaScript code, if statements, for loops, objects, all that does not change. But TypeScript then adds more features to the JavaScript syntax. And that's also important. Unlike React, TypeScript is not a library for JavaScript, so it doesn't use JavaScript features to build new features on top of them, to build functionalities around them, but instead it extends the core JavaScript syntax. And most importantly, it adds static typing to JavaScript. And that's also where the name comes from, TypeScript. It adds static typing to JavaScript, because JavaScript on its own is actually dynamically typed. And what does this mean and why is this useful? For this, I prepared a very simple example here, which you find attached. This is not a React app. This is a standard JavaScript function and a standard HTML file which has no actual content, but which imports this script file. Now, if I open this file in the browser, simply by copying the path here and then opening that path in the browser, if I reload this page and open the developer tools, I see 7 here in the developer tools in the JavaScript console. And I see 7 here because in this script file, I define an add function, and then I call this add function and store the result in this constant, and then I log this constant. So that's standard JavaScript, nothing fancy here. Now, JavaScript has types. JavaScript knows the concept of types. For example, here, the 2 values which I'm passing in are of type number. And that's something JavaScript knows on its own without TypeScript. The important thing just is that JavaScript, as I just mentioned, is dynamically typed, which means that this function here does not expect any particular types. It just knows that it will receive 2 parameters, and that's it. So it's not statically typed. The types for this function are not announced ahead of time. Instead, it just takes whatever it gets and then tries to execute this code. And that code happens to work with numbers. But this code also happens to work with strings. And hence, if I convert my 2 numbers into strings here by wrapping them with quotes, then I got 2 different types here. I got 2 strings instead of numbers, which are types JavaScript knows. And if I change it like this and save this file, if I reload, You see, now we get 25 here, because now the plus operator does not add these two arguments in a mathematical way, but instead it concatenates two strings because it receives two strings here. And that shows why just JavaScript is okay and great, but why it might not always be best. Why having static typing could enhance your code and prevent errors like this. Now, of course, you might say, which error? I can simply not call add like this. I just make sure that I always pass in two numbers and I won't face this problem. And that's true, but in a bigger project with lots of code files and potentially a lot of people working on the code base, you might sometimes call a function or use some object in an unintended way. And then you could run into problems like this because nothing is warning you that this is not how you should use this function. Nothing is telling you that this function actually wants two numbers instead of two strings or any values. And that's where TypeScript can help us. Because with TypeScript, and I'll show you this code even though we haven't installed TypeScript yet, but I have it installed on my system already, and we will install it together in the next lecture too. But let me show you this first. So with TypeScript, if I copy this code, what we will be able to do is we can add type annotations here, simply by adding a colon after our parameter, and then adding the type which should be used for this parameter. And I'll do this for B as well. And we'll also not just be able to use type annotations on function parameters, but as you will see throughout this module, we can use types in many other situations as well. So now I'm making it clear with TypeScript that here I actually want two parameters which both should be of type number. And hence, I already get an error here in my IDE, which tells me that this argument of type string is not assignable to a parameter of type number. Pretty helpful. And with that, I can catch such an error, such an unintended use of this function before I run and test my code. And that, of course, allows us to write better code in the end because we can avoid such errors and we don't have to track them at runtime, but we see such errors right when we start writing code. And that's why using TypeScript could be worth a thought. So now that we know what TypeScript is, that we can add types to our programs with it, and how the syntax generally looks like, let's make sure we can all use TypeScript. And therefore, if you search for TypeScript, you can visit typescriptlang.org, and that's the official TypeScript webpage where you can learn more about TypeScript and where you can also learn how to install TypeScript. As a side note, if you want to learn way more about TypeScript, I also do have a complete TypeScript course where I dive deeply into TypeScript. In this module, I'll just cover some basics. So if you want to learn more, my full course might be interesting to you as well, or the official docs, of course, in addition. So now to install it locally, we can click here on install locally. And now we basically need to run this command here. Now for that, we need to make sure that Node.js is installed, but we needed this for this course and for using React anyways, and therefore that should already be installed. So therefore we can now run this command to install TypeScript. And running this command will install TypeScript into a specific project. If you want to install it globally on your system, then you need to run npm install -g TypeScript. But often installing it just into one specific project is enough so that you can then use TypeScript in that project into which you install it. And therefore, that's what I'll do here now. I will open my terminal, which is integrated here into this project, and run npm install TypeScript. And actually for this, I'll first of all run npm init -y to create a empty package.json file, because we'll need that to install dependencies, and then I'll run npm install TypeScript. And this will now install TypeScript into this project. Please note, this is still no React project. This is still just a standard web project. We'll move towards our React project a little bit later. So now TypeScript is installed. With that installed, we can now invoke the TypeScript compiler. And that is really important. As you learned, TypeScript is a superset to JavaScript, extending the JavaScript syntax with those extra types. Now, the important thing to note is that TypeScript code does not run in the browser, though. So if you try to execute TypeScript in the browser, it will fail. Therefore, we need to compile TypeScript to JavaScript. And during that compilation process, all our type annotations will be removed because JavaScript doesn't know those annotations. But it's during this compilation step where we will be notified about errors, in addition to the notification we get in the IDE already. So it's this compilation step which then will warn us of potential code problems if we haven't spotted them in the IDE before. And then it's that compiled code which will run in the browser. Now, to invoke this compiler, we need to run this command here, npx tsc. So now if I run npx tsc like this, you'll see that I get an error though. I get this error because if I run this command just like this, then it expects a TypeScript configuration file in that project folder that tells TypeScript which files to compile. Now we'll add such a configuration file later. For the moment, we can run this command slightly modified. We can point at a file that should be compiled. In this case, with typescript.ts. So if I run npx tsc with typescript.ts, then this file is getting compiled. And hence now here I get one compilation error, the same error my IDE warned me about before. So if I haven't spotted it in the IDE, now I get an error here. Now you will notice that a no typescript.js file was created nonetheless. That simply happens because by default, even if you get an error during the compilation, it still completes. It just warns you because of that error, but it still gives you a JavaScript file. And this JavaScript file, sorry, this one here, is now based on our TypeScript file. And you see it's almost the same code, just without the types. And actually it changed const to var because by default right now it still also compiles the code such that it runs in older browsers as well. That is something which can be overwritten with the TypeScript config file, but we don't have such a config file yet, and therefore we have this code change as well. But of course you see that other than that, it's the same code as we wrote in the TypeScript file. Now, of course, we should get rid of that error though, otherwise using TypeScript doesn't make any sense, and hence I'll convert my two strings here to numbers, and if I save this now, the error is gone in the IDE, and if I now compile again, this also compiles without errors, and we still have the same JavaScript output as before. But now it's this JavaScript file which we could import here and use here. If I now save this and then reload this page, I get 7 again. But now, if we continue working in the TypeScript file and then compile it to run in the browser, now we actually protect ourselves against errors like we had it before, thanks to TypeScript. And now with that installed, and now that we understand what this compiler does and how this generally works, let's dive into some core features you need to know when working with TypeScript before we then thereafter see how we can use TypeScript with React. Now let's dig deeper into TypeScript. And for this, I'll add a new basics.ts file in which we'll dive into some core basics you need to know about TypeScript. And for that, I want to start with the basic types you can work with in TypeScript, which you will need all the time. And that will be our primitives, which we know from JavaScript, numbers, strings, and booleans. And then, of course, we also have more complex types like arrays or objects, for example. And then thereafter, we'll also talk about function types, parameters, and much more. So that's generally what I want to talk about here. And let's start with the primitives here. The primitive values we have in JavaScript are numbers, strings, booleans, and also null and undefined, and also symbols, but we can ignore that. And number, string, and boolean, as well as null and undefined, are the important ones, therefore. Now, if we have a variable, let's say the age of a user, and we want to make it clear that in there we want to have a number, we can make that clarification with TypeScript by adding a colon after the variable name, and then simply specifying the type of value that should be stored in this variable. And then we can finish this variable declaration here. If I then later assign a value, assigning a number is okay, including floats, so numbers with a decimal place, but assigning a string would give me an error. That's what we saw before with that function and its parameters as well. Now, of course, we can also assign a value here right away. We don't have to have this declaration without a value assignment. Both is allowed. Now, we also can, of course, have a username, which should be a string, and for that, we can assign a type like this. String is the type we want to use here. And one important note here, in TypeScript, it's number and string written like this with lowercase starting characters. It's not number like this. We don't get an error if we use that, but this actually points at the number object in JavaScript. We want the number primitive type, which starts with a lowercase n. The same for string. We want the primitive type, which starts with a lowercase s. And then, of course, here we can assign a value. And we can also, of course, store Boolean values like is instructor and add Boolean as a type assignment so that thereafter I may store true or false in that variable. And these are our core primitive value types which we can assign, in this case to variables. Before we also saw how we set types for function parameters. And we'll see more places where we can set types in the next minutes. Now, as I mentioned, we also have null and undefined as types, but we don't typically set something to be null. If I set hobbies to null here, then this would be possible. But then whenever I try to assign anything, I get an error, which of course is not too useful. Instead, we'll use null and undefined in a slightly different way, which we'll learn about in a couple of minutes. So numbers, strings, and booleans are the core primitive value types we should be aware of. Now let's talk about the more complex types, so arrays and objects here. And let's start with arrays. If I have my hobbies, that might be an array of strings. Hence, this type assignment is wrong. This allows me to store a single string in hobbies, but I want to have an array of strings. To tell TypeScript that I want an array of strings in there, we can instead assign this type, string with square brackets thereafter. This tells TypeScript that we want to have an array of strings in hobbies. And of course, we could have the same with an array of numbers, an array of booleans, whatever. But here I want to have an array of strings, and that allows me to store an array of strings in there, like this. Now, this is possible. If I would add a number in addition to the strings, I again would get an error, because that's not a string, and I'm making it very clear that only an array of strings may be stored in hobbies. So that's how we can set up array types. Now we also can set types for entire objects. Let's say I have a person variable, and in there I don't want to store a name or an age, but an object. I want to be able to store something like this. An object with a name and an age. Something like that. That should be stored in person. Now, of course, this works like that because TypeScript out of the box without configuration is quite forgiving, and it by default allows me to store any value in a variable. It has a special any type for this, which we can see if we hover over person. The default type assumed is the any type, which we can also explicitly set like this, which simply tells TypeScript, I don't want to tell you anything about the types of values stored in this variable. Anything is allowed. And that, of course, is a fallback type, which you typically should not use, because that kind of defeats the entire purpose of using TypeScript in the first place. With the any type, you're basically back to standard JavaScript. So it's the default, but of course, it's not what I want to keep here. Instead, I want to make it very clear which kind of object can be stored in person. I want to allow this object, for example, but storing another object with a different structure, where I have, let's say, just a Boolean in there, that's something I don't want to allow. And for this, we can again add a type assignment, but now we want to add an object type, a type defining an object. And for this, we then add curly braces, just as we do it when we create an object. But please note that this is not on the right side of an equal sign here. So we're not creating an object here. Instead here, it's in the place where we set a type for a variable on the right side of this colon after the variable name. And therefore, this here is actually a type assignment. And hence here, we're not creating an object, but instead we're using a TypeScript feature here, which is the object type definition. So we're defining the type for an object. We're defining the structure of an object. And here we can then, for example, say that person should store objects that have a name field where the value of that name field is a string, and which have an age field where the value is number. So where the value is of type number, I should say. And with that, we're telling TypeScript that only objects that have this kind of type should be storable in that variable. That's why I can store this object here, because that object down there has exactly the structure I'm defining here. It has a name field, which has a string as a value, and the age field, which has a number as a value. On the other hand, this object down here is not storable, and hence I'm getting an error here because it is having the wrong type. This object's type would be that it has an isEmployee field, which stores a value of type Boolean, which does not match this type description here. So I'll comment this out. And that's how we can define array types and object types. Of course, we could also combine these two. If I wanted to have an array full of people, so full of people that have this type signature here, then I could set the type of people here to this object type. So I'm repeating this, but as an array by adding square brackets thereafter. Now I'm saying in people, I don't want to store a single object of that structure, but an array of such objects. And that's how we can then already get a bit more advanced by combining different TypeScript features and by combining different types. Now that we learned about those base types, before I'll dive into functions and parameters, I want to talk about type inference. In all those examples which are listed here, I always declared a variable with a type assigned, and then in a second step, I set a value. Now, often in programming, you do that in one step. You create a variable, and you then also immediately assign an initial value. So therefore here, let's talk about type inference. And let me show you what that is. Let's say we have another variable down there, the course variable, and in that course variable, I want to store the name of a course, like React the Complete Guide, like this. Now, if I create this variable like this, and thereafter I try to store a number, for example, the course ID, then you will see that I get an error because the type number is not assignable to type string. But why am I getting this error? After all, I don't define a type anywhere. Well, here TypeScript used its powerful feature of type inference. By default, TypeScript tries to infer as many types as possible. So it tries to know which types are used where without you explicitly stating those types, which means that you need to write less code. I could also set my type here, as we learned it. That would not be wrong, but it's redundant. Because if you immediately initialize this variable with a type, TypeScript will look at the value type here, so it will see that we stored a string in that variable, and it will then use that value type as an inferred type for this variable. And if you then try to assign a different type thereafter, you'll get an error because of type inference. And it is considered a good practice and a good idea to embrace that type inference feature, so to not unnecessarily specify the type in addition. You can do that, you can explicitly state the type, but it's really redundant. It just means more work from your side, and therefore you should not do that. You should instead stick to that type inference and use it whenever possible. And that's another super important feature which I wanted to highlight here. Now, type inference is great, and in general, up to this point, we already learned quite a bit about TypeScript and its core types. But up to this point, we also always had the scenario that every variable took just one type. So we always had just one possible type that could be stored in a variable. Just a number, or just a string, or just a boolean. And often, that is what you need. But sometimes you want to allow multiple different types. Let's say here for the course. We might be fine with storing a string in there, but maybe storing a course ID as a number should also be correct. It really depends on what you're building. It's not unrealistic that we could have a variable where both a string as well as a number should be allowed. Or that you have some variable which should allow two different kinds of objects. And for this scenario, that you have more than one type which you want to allow, you have a feature called union types. A union type is a type definition that allows more than one type. You add it like any other type assignment by adding a colon after the variable name on the left side of the equal sign, and then your type. Now, I mentioned that explicitly setting string again here would be redundant. But it's not redundant if you don't want to use the type inference here, but if you instead want to specify such a union type, hence allowing multiple types. You set up such a union type by adding a pipe symbol after your first type, and then adding another type like number. And you can have as many types which you want to allow here as needed. But here I just want to have string or number. And now you see that that error which we had down here before is gone, because now we are allowing a number alternatively to a string value. And of course you can use such a union type anywhere where you have a type assignment, not just when you're using type inference. I could also use a union type up here, allowing username to be a string or let's say an array of strings, for example, so that we have first and last name in an array, for example. That's also something I could allow here. Union types are another key TypeScript feature which allows you to define more flexible values and types. Now, the more TypeScript code you're going to write, the higher the chances that at some point you might be repeating some type definition. And we're actually already doing this here. Here, for people, I'm saying that I want an array of this kind of object. so that I want an array full of objects that have this structure, and that's the same object I have up here for person. The same type definition, just in the non-array form. But the object type is the same. Now you can, of course, duplicate the type definition, but it's more realistic that you want to avoid that duplication. And for that, you can create a so-called type alias. You can define your own base type, in which a more complex type definition is stored, and then use that type alias instead of repeating the entire type definitions. For that here, for example, before we use this object type for the first time here, we can define such a type alias with the type keyword. And that's a keyword which does not exist in standard JavaScript, but which is added by TypeScript instead. Now, after this type keyword, you use any name of your choice, which will be your new type name. For example, person, like this. And then after the equal sign here, you then have a type definition, because this is a pure TypeScript feature. This will basically be thrown out of the window when the code is compiled to JavaScript. So here on the right side of the equal sign, it's not a JavaScript value, but instead a type definition. And that could be our object type definition here, which I now store here in this person type. And now in all those places where I used this object type, I can use my alias instead now. And it's therefore still the same type, but I only define it once, and then I can repeat it in all the places where I need it. And I can still also change it like I'm doing it down here to use it just as person like this, or to use it as an array full of persons. That also works. And that's the very important feature of type aliases, which can save you a lot of typing work and which can therefore make your code more concise and easier to maintain. Now, there are a lot of other core TypeScript features which I do explore in greater detail in my TypeScript course. To come to an end here for this introduction, so that we can move to our React example and see how we connect TypeScript with React, there are just two last features which I want to cover here. And that would be functions combined with types, and then thereafter generic types. Let's start with functions and types. And I'm saying function and types because when we work with functions, there are different places where types can be assigned. Let's start by adding a function here. Let's say the add function again, which we saw before. The add function can get parameters, of course, like any function, just as I did it before. And then for these parameters, we can assign types. That's what we saw before here in this first example. Just as we can set types for variables, we can also set types for parameters. We can make it clear that here we want to allow numbers, for example. And then I can return a plus b. But with that, we also have one inferred type here in this function. And do you see where we're using type inference here? Well, here in this function, I am returning a value, and that tells TypeScript something about the return type, the type of the returned value of this function, and it infers this type. We can see the type it infers if we hover over add. Then we see the TypeScript definition of this function, and we see that, of course, for the parameters, we have the two types we set up, the number types. But then here, after this function name and the parameter list, this colon here and this type here, that's not coming from us. We haven't added this code. Instead, that's the inferred return value type TypeScript infers here. So TypeScript knows that here it will get a number as a return value because it sees that this code with these parameters, which are always of type number, can only return a number. There's no other value that could be returned. And that's why this number return value is inferred. We could also explicitly set it though. We can set the return type of a function by adding a colon after this function parameter list and then setting the return type here, like number or string, or a union type. That would also be possible. That's something we can do. But just as before, if you don't have a reason for doing that, you shouldn't do that. TypeScript already infers a type here, and if that's the type you want to stick to, then there's no need to explicitly define it yourself. Still, I want to mention this, that functions, when we work with types, don't just use types for the parameters, but also for the return value. That's easy to overlook, but it makes a lot of sense, because a function, after all, does not have just some input, it also has some output, and hence it has a return type. Now, there is a special return type, which is also worth knowing. And for that, let me add a print function, where I get a value, and that could indeed be of type any, because the only thing I'll do with that value is I'll console log it. So I don't really care about the concrete type of this value, I'm just logging it. Now, one important note about naming this function print though, which I unfortunately only discovered after I named the function like this. Of course, in JavaScript there is a built-in print function already, so now this function will clash with this built-in function, and hence if you would try to compile this TypeScript file, you would be getting an error because of that, so maybe just name it print output or something like that to avoid that error. But the important thing about this print function now is that this function does not return anything. It has no return statement. And therefore it has a special return type called void. Void is basically comparable to null and undefined, but it's only used in conjunction with functions, and it means that this function never returns. So if I want to work with the returned value from that function, I will work with undefined. And that's that special void type for functions, for the return value of functions. Now we'll of course work a lot with functions once we start working with React and TypeScript, and therefore we'll then see all those function types in action there. I want to conclude this basic introduction to TypeScript with a slightly more advanced yet very important TypeScript feature, and that would be generics. Now this can be tricky to wrap your head around, but I'll try my best to explain it such that it makes sense. Let's say we have a function here, which I'll name insert at beginning, and this function takes an array and a value as parameters, and the array should be an array full of any kinds of values, and the value should be any kind of value, because I don't care in this function if it's an array full of numbers or strings or of person objects. Whatever it is, what I want to do in this function is I want to create a new array, for example by using the spread operator and copying the existing array. That's a standard modern JavaScript feature, also supported by TypeScript. And then in front of that old array, I want to insert the value. And then I want to return this new array here. That could be a utility helper function which we create to have a function which we can easily call to add a value in an array without changing the existing array. So the advantage of this function could be that the original array never changes, but instead we're getting a brand new array. Now for this, I could of course have a demo array with, let's say, 3 values. And then I get my updated array, where I call insert at beginning, and I pass in the demo array, and then a value of -1, let's say. With that, I know that the updated array will be this array with -1 inserted at the beginning. So this will give me -1, 1, 2, 3. And hence, thereafter, I might want to do things with that array, which I can do with an array full of numbers. But the problem is that updated array, if I hover over it, is inferred to be of type any array. So an array full of any kind of values. TypeScript here doesn't pick up that it's an array full of numbers. Why? Because here I have any as a type. And I can't say that I only want to allow numbers here, because what if I want to use this utility function with an array full of strings? So we need any, but at the same time, that kind of removes all kind of TypeScript support we might be getting after calling this function. We're not getting any good TypeScript support for updated array thereafter, because that is inferred to be an array full of any kind of objects or any kind of values. And that's not useful. If I then, for example, try to access the first element and call split here, which I could call on a string, I don't get an error here. I would get a runtime error instead, because I can't call split on a number. But again, TypeScript doesn't know that the first value in updated array is a number. We know it as a developer, but because of our type definitions here, which we need, TypeScript doesn't know it. And to work around such problems, we have this feature of generics. And that's why I had this lengthy introduction here, because it is important to understand why this feature exists. With this generics feature, we can convert this function to a generic function. For this, we use a special syntax here. After the function name, in front of the parameter list, we add angle brackets. And that's now not a standard JavaScript feature, but really only a feature we can use here since we're using TypeScript. And in here, we can define a generic type, which will only be available inside of this function. Typically, that's called T for type, but any identifier of your choice is okay. Now you can use this type in your function, including the parameter list. And here I'm saying, I want to use this for my array. So my array will be full of t's and my value. This should also be of type t. But how does this help us? Well, like this, it of course is just very cryptic. But now when we call this function, now TypeScript actually is able to understand that it should look at the concrete values of the arguments here. And it understands that this is an array of numbers and this is just a number. And therefore it understands that updated array will be an array of numbers. Because of this generic type feature, because we're telling TypeScript that the type here is actually not any type. It's not any kind of value. Instead, we tell it that the type of this array and of this value should be the same. Just that this is an array, but it's an array full of the same types of values as this single value has it. And that's an important piece of information. Therefore, TypeScript is able to look at the type of demo array, which it knows. It knows that this is an array of numbers. It's able to infer this. And it looks at this type. And then it knows that logically, the array which gets constructed here has to be of the same type as the input array. It's able to infer this here. And hence, it's able to infer that what we get back here has to be an array of numbers. And if I would call insert at the beginning here with an array of strings, like this, and I then pass in a string here, and I have my string array here, TypeScript is also able to infer this correctly, because again, it looks at this type, and it knows that the return type is of the same value as this type, as the input array, and hence it again infers this correctly. And therefore, for the updated array here, where it knows that it has to be an array full of numbers, it's now able to warn me when I try to call split. It tells me that this does not exist on type number. So that's this important feature of generics. It simply helps you write functions in this case, which are type safe yet flexible. They are flexible, they work with any type, but then once a certain type is used, for that function execution, that type is locked in and known. And that allows you to get the best of both worlds, flexibility and type safety. Again, I am fully aware that this generics feature can still be tricky to wrap your head around, but we'll also see it in action soon when we start working with React and TypeScript, and then, combined with what you learned here, it should become clearer and clearer how it works and why it's important. And speaking of that, let's now leave this basics file and this non-React project, and let's instead move towards a React project which is using TypeScript. Now that we covered these basics of TypeScript, it's time to actually dive into React and TypeScript. And for this, we need to create a new React project where we get this development server and this build process, which we can run if we want to deploy our application. But we need a React project that is configured to use TypeScript instead of vanilla JavaScript, which is the kind of React project we used up to this point in this course. Now, the great thing is that we can still use Create React App for that. If you search for Create React App, you should find the Create React App docs here on createreactapp.dev. And on this page, you find instructions on how to use Create React App, and there you will also find instructions on how to integrate TypeScript. For that, if you click on Building Your App here, you find the Adding TypeScript document. Now, this general page structure can, of course, change over time, so the way you find those instructions might change, but you can also Google for Create React App TypeScript, and that should then directly lead you to that Adding TypeScript documentation you're looking for. And here you can learn how you can add TypeScript to a React project that is using Create React App. And it's of course easiest if you simply start a new project with TypeScript integration, though you also get instructions on how you can add TypeScript to an existing project. Now, we will simply create a new project here though, and therefore I will just grab that command here, npx create react app, then my project name, my app name, and then this important dash dash template flag, which we add on this command, and which we then set to TypeScript as a value. And that will use a special template for creating this project, which gives us a project configured for TypeScript. So if we grab that, we can run this command. And here what I'll do is I'll open a terminal in my project here, and I'll run this command, but I'll rename this to React-TS, this project name, and then hit enter, and this will now create this new project, this React TypeScript project in my existing folder here. Now let's wait for that to finish, and then we'll continue. Now here it did finish, and with that I got this new React-TS subfolder. And what I'll do now is I'll create another folder in my overall project, which I'll name TS Basics. Basics. And then I'll just move that old configuration into that TS Basics folder here. So those files on which we worked in the previous lectures. And I'll delete that node modules folder there. And now we have these two folders side by side, and it's of course the React-TS folder in which we'll work now. And for this here, I'll first of all cd into this React-TS folder, and then with npm start we can still bring up that development server, just as we do it throughout the entire rest of this course. But now, here, we actually got a React project configured for TypeScript. If you visit localhost 3000, you should still see that starting page, this default app we get here out of the box. But if you have a look at that source folder, then you will notice that instead of .js files, we have .tsx files in there. And that indicates that we're using TypeScript, and it's .tsx instead of just .ts because we're using this JSX syntax in there. And if you are doing that to avoid unnecessary complaints by your IDE, you should be using .tsx as an extension if you're using JSX in those files. And other than that, it's basically just the same code we saw before in this course. There's really nothing special about that. Now, one important word about that dev server, which we started here again, this works as we're used to, but of course, keep in mind that it's now doing one more thing behind the scenes. It's actually compiling our TypeScript code to JavaScript code, which then is taken and optimized further. Before, with just React and vanilla JavaScript, we just had this dev server which takes our JavaScript code, bundles all the files together, and provides certain optimization steps. Now we still have all of that, but in addition, we have that extra TypeScript to JavaScript compilation step, which also takes place behind the scenes. So we don't need to convert our TypeScript files manually to JavaScript here. We don't need to compile them manually or call the compiler manually. That happens behind the scenes. It would also happen automatically if you build your code for production by running npm run build. That's just a little side note, which I wanted to add here. Now, before we dive into that code and clean it up a bit, I want to talk about our dependencies in the package.json file though. In there, we generally got the same dependencies as before, React and React DOM and React scripts, but we also see a couple of extra dependencies. Specifically, we find TypeScript in there and also these types dependencies. Now, TypeScript, of course, is the language, the compiler for TypeScript, which is installed into this project so that we can use TypeScript in this project. That's also what we had in this TS basics part we worked on in the last lectures. There we also installed TypeScript. But we now also have these extra types packages, and these are important packages. These add types packages act as translation bridges between vanilla JavaScript libraries and TypeScript projects. So, for example, we're using React and React DOM as libraries in this project, and these two libraries are, of course, written for just JavaScript. After all, we worked with React and React DOM throughout this entire course with just JavaScript. Now, in order to also work with them in TypeScript and get great TypeScript and IDE support, great auto-completion, and so on, we need translations between these raw vanilla JavaScript libraries, which are written for JavaScript, and a TypeScript project. So extra type annotations that are added to these JavaScript libraries, you could say. And that's what add types React and add types React DOM provides. Not all libraries need such translations because some libraries actually already have built-in type annotations, even if you can use them with just JavaScript as well. But some libraries do need these extra annotations, and that's why here we got some extra annotations. Now, with that, we can leave that, and with that, we can now dive into writing some React code with TypeScript. Now let's write some TypeScript code, and for this you find my created React TypeScript project attached so that we all have the same starting point, even if that default app which is created by Create React app should change over time. Now, I didn't change anything here yet. At the moment, I have all these starting files, and therefore I'll first of all clean them up a little bit. I'll delete the app test file, the logo file, the report web vitals and setup tests file here. I'll delete all these files. The React app env file here, that's a file we should keep around to have TypeScript linked into our project, so to say. But in index.tsx, I now want to remove that web vitals import. And I'll actually also get rid of strict mode here. We don't need that here. And get rid of that part down there. And then here in app.tsx, I want to get rid of that logo import. We can get rid of the React import. In modern React projects, you learned that you can omit this, and TypeScript projects are no exception here. And we can get rid of all that JSX content except for the div for the moment here. And then app CSS, I'll now also delete all that code here. And then index CSS, I will actually keep that default setup here. I'll just get rid of the code selector, but I'll keep the body selector here and keep that default font family, which is assigned. That is actually fine from my side. And with that, we cleaned up this project. We can save all these files now. And now that it is cleaned up, let's write some React TypeScript code. And the most important part here, and the good news, is that generally, you still write the same code as you did it throughout the rest of this course. It's not like everything changes all of a sudden. And that hopefully makes a lot of sense if you have a look at this app.tsx file or the index.tsx file. That code here is exactly the same code as you saw it throughout this course. There's no difference here. No special type annotations because we don't need them here. We're generally using TypeScript's built-in type inference feature here, but in general, this code here simply doesn't use a lot of types. But that's something we're going to change throughout this module now, and you are going to see where you can use TypeScript to actually enhance your React code. Now, to dive into React and TypeScript, I want to keep it fairly simple, and we'll simply build a basic to-do app. A basic to-do app where we can add to-dos and delete to-dos. That will not be a super complex or fancy app, but it will allow me to show you all these core TypeScript features you should know. And for this, I'll start by adding a new components folder in the source folder. And in there, let's add a to-dos.tsx file. And that will simply be a file that should hold a new React component. Now, a React component still is a function or a class, but as we did it in the rest of this course, we'll focus on functional components here. So here we can add this to-dos function, and then of course also export it to make it available outside of this file. Now, just like all the React components we built thus far, we need to return some renderable content, and that will typically be JSX. And that again does not change at all. So in here, let's say we want to have an unordered list because we have a couple of to-dos here. And in there, we have a couple of list items, of course, with our different to-dos, like learn React or learn TypeScript. And we'll later make those to-dos dynamic, and we'll make sure that a user can enter them. But for the moment, I'll just create this functional component like that with the hard-coded JSX code. And now we can use this to-dos component here in the app component, simply as we always did it by importing to-dos from components, to-dos. You can omit the file extension here. And then here in that div, or even without the div, doesn't matter, you can output to-dos. And we can actually also get rid of app CSS here now that I think about it, since it's empty anyways. But with that, if we save everything and we go back and reload this page, we see our to-dos here. And that shouldn't be too exciting, of course, because that's a very basic React component, but it shows us that we build React components generally as we learned it. But it gets a bit more interesting if this to-dos component actually does not have hard-coded to-dos, which we output here, but if it instead receives to-dos through props, which we want to output. So let's delete those hard-coded to-dos here. And now let's say we get some props here. And now my goal is that the props should have items or a to-dos prop where I can then map through all those items to then output the list items. And you can already see here that now I'm getting those red squiggly lines here. And if we hover over that, we see that props is declared, but its value is never read. So we're getting a warning that we're not using props. And that's a little extra help we get in this TypeScript project, which we don't necessarily get in a vanilla JavaScript project. We are warned if we have some unnecessary code that we're not using. And we also get this warning that the parameter props is implicitly of type any. And that means that we did not assign a type here. We're not making it clear which kind of type this is, and therefore we're basically not getting any TypeScript support. And that's why you can configure TypeScript such that it warns you if you are implicitly using any. If I now explicitly set this to type any, it would be okay. I'm now explicitly saying I don't have any more specific information about this props argument. It is of type any. It could be anything. And that's then fine. But if you don't set this type explicitly, you are implicitly assuming that you don't know anything about that type, and that's why TypeScript is warning us here. We shouldn't make this implicit assumption. By the way, you can configure the strictness of TypeScript here in the tsconfig.json file, but I'll come back to that a little bit later. For the moment, what we need to do here is we need to make it clear which kind of props we're getting here, what the type of props in this function should be. And of course, we can do this with a type assignment here. And now we could actually say that props is an object type. So we add those curly braces. And again, that's not a value here. That's a type definition. It's an object type. And we know that props in React will always be an object with all the attributes we added on our own element here in app.tsx as key value pairs. So here we could say that we expect to get some to-dos or some items, and that then in turn could be an array of strings, let's say like this. That's how we could say that props is an object with the items key, which then itself holds an array of strings as a value. But that would actually not be 100% correct. Props does not just have the key value pairs we added on our component when we use it in JSX. Instead, props is an object which does have those key value pairs, but remember that there also always is a special prop, the children prop, and we don't even know the type of that yet. Now we could find out which type that should be and then add it like this, but it would quickly become cumbersome if for every component that we're defining that is using props, we have to always add those built-in props to that object and then also our custom props. And because that's cumbersome, and because we have that base prop object, which we get in every component, which for example includes this children prop, React gives us a different way here, or React and TypeScript gives us a different way here. We can use such a generic type, which you might remember. We can use such a generic type, or to be precise, a functional component out of the box can be converted into a generic function. Which then simply means that in the end, our functional component will be configured such that we make it clear that it will be a React component function and that it will have all those base props like children, And we can then define explicitly our own props, like the items prop, for example, here, that should be combined into the props object. And if that's not 100% clear yet, I'll show you how it works. We can actually write this a little bit differently and use this arrow function syntax, which we used throughout this course all the time, so that our to-dos constant here holds this React component function. And now we can assign a type here to this to-dos constant. And the type here should actually be React, for which we need to import React from React, like this, .fc. Now that's a type defined in this React package, or to be precise, by this types React package, but we can just import React from React and the rest will be done behind the scenes. So this is a type definition here. Now, if I hold Command and click on this, or Control and click on this, I see the type definition here, and I see that it's a function component, which is yet another type definition built into this React package. Now, what React FC in the end does as a type definition is it makes it clear that this here is a function that acts as a functional component. That's what FC stands for, functional component. And you see that now the red squiggly lines for props are gone. And if I now try to use props here in my JSX code and I add a dot, I see that I now get this auto-completion for the children props. So now, simply by adding this type annotation, Typescript and my IDE, therefore, which is very smart about that, understands that this is a function that receives a props object as an argument, as a first argument, which will be an object that always has a children property, a children field. And it understands this, it knows this because of this type assignment here. Now, I mentioned that generic types would be important because this is actually a generic type. And we can now merge our own type definition for this props object, so our own props this functional component will get, with those built-in base props like the children prop. And for this, we add angle brackets after FC here, and then between those angle brackets, we define our own props. Now, when we use angle brackets here, we actually use them slightly differently than we did before when I introduced you to generic types. There, we used angle brackets to create our own generic function that has this generic type parameter, if you want to call it like this generic type t here, which then could be used inside of the function, and which in the example I gave you then was inferred by Typescript when we used that generic function. Here we're using it slightly differently. Here, React.fc already is a generic type. It describes a type defined by the React package that is actually generic. So that type internally is also defined with those angle brackets. And here, when I also add angle brackets in our code, I'm not setting up a new generic type with some placeholder type t, but I'm plugging in a concrete value for that internally used generic type. So for that type t defined by that React FC type. And I'm doing that here because here we can't let Typescript infer that generic type as it did it in the example I showed you before. We can't let Typescript infer the type here because here we're not calling some generic function with some parameters where the values then could be used for the inference, but instead we're defining a function and we want to let Typescript know how it should then treat this function internally. That it should get some props defined by us and merge those with some base props like the children prop, which all functional components have. And what you see here, therefore, is the other side of generic types, that you use a generic type and you explicitly set the concrete type that should be used for this usage of this generic FC type. Here I'm saying this FC type is generic and the concrete value I'm plugging in now is my own props object where I describe my own props for this specific functional component. And it's generic because different functional components have different props definitions. And that's how we do that with React and TypeScript here, how we can also use this generic types feature. Now, this angle bracket syntax is the generic type syntax here. And by adding it here, we actually unlock a feature built into this FC type, which we're using here, which will merge whichever object type we're defining here with that base object type with the children property. And here we could then say that we want to have items, which is an array of strings. And what this does now is that here, if I again type props dot, it still knows that there will be a children property, at least that there could be a children property, but that we now also have this items property, which will be a string array. And it knows that because we now merge our own prop object definition with that base prop object definition. And that might all sound super complex, but it's just sounding like this because I'm explaining the behind the scenes stuff here. In the end, using it is super simple. You build functional components with React and TypeScript by using this React FC type here on your functional component constant here. And then you use those angle brackets, and between those angle brackets, you define your own props, your own prop object type if your component gets some custom props. And then in the component, you can use those custom props. And here we can then use props items, use map, and we get auto completion here for this array method because TypeScript knows that items will be an array because here we defined that it will be an array. And we can then map all our items and turn every item into a list item here where I output item and where I set the key equal to item. So for the moment, my key will just be the string inside of this items array. And now I'll reformat that. And that's now this finished to-dos component with proper type annotation. Now, the great thing about using TypeScript with React is now not just that this is now more descriptive and we get the auto completion here when we work inside of this component, though that's already pretty good, but that now you also see we have an error in app TSX. Because of our type annotations, React now understands, or this project setup to be precise, now understands that we're using this to-dos component in an incorrect way. Because I'm making it clear here in this type definition of the to-dos component that this component will have a items prop. And this is not an optional prop. We could make it optional by adding a question mark here, but then here we need to handle the case that we don't necessarily have items. But here it's also not optional at all, and therefore we have to add it here. And that's another strong reason for using TypeScript. We can now really describe the shape of our components and which props they need, and therefore using our components incorrectly and, for example, not passing in all the props a component needs is pretty much impossible because we get errors like this directly in the IDE now. So here I can now add my items and for the moment just add some dummy to-dos here like learn React and learn TypeScript, reformat this, and now all errors are gone. And we now see that output again, but now, thanks to our props, and those props now work properly thanks to our type annotations. And I did spend a lot of time talking about this type annotation, but I hope it's clear how it works, and even more importantly, it's clear how you use it. And as you see, using it is super simple. It's this type annotation which you want to add to every custom component you're building. And then if you are using your own props, you add this generic type and you describe your props between those angle brackets. Now we got started with our own components with props. Now let's refine this. At the moment, a to-do is simply a string, and hence a list of to-dos is an array of strings. That could be what you need, but it would also not be unrealistic that every to-do is an object. An object with an ID maybe, with the to-do text, maybe a title and a subtitle, and maybe then also more metadata that is attached to a to-do, like the author, the time when it was created, if it's currently active or not active. There are endless ways of describing a to-do. I don't want to incorporate all those ways right now, but I definitely do want to refine it a little bit. And therefore, I'll add a new subfolder in my source folder here, which I'll name models. You don't have to name it models, you can name it however you want, but I name it models because I want to describe my different data models, my different kinds of data I'm working with in this project. And in there, I'll add a todo.ts file, not tsx, but ts, because I'm not creating a component in there. It's also not in the components folder. And in this todo.ts file, I want to describe how a to-do looks like. And for this, I want to create my own to-do type. Now we can do this with the type keyword. There also would be the interface keyword, which we can use as an alternative. Or we create a class, which we then even could instantiate. And I'll do the latter here, but either approach would work. With that, I create a class to-do, and we create this class basically just as we would do it in vanilla JavaScript. Modern JavaScript has classes built in, and I'm just using that feature here. It's also supported in Typescript. And now here we can describe how our class should look like. And here we now got some slight differences compared to how we do this in just JavaScript. Because when working with TypeScript and classes, if your class has different properties, different attributes which you want to add, then you don't have to do this in the constructor as you do it in vanilla JavaScript, but instead you can add them directly here in the class between the curly braces, as you're used to from some other programming languages like C#, for example. And here I want to make sure that a to-do object will always have an ID and a text field for now. And for this here, I'll add my ID field, and then assign the type for that, which will be string here. And then I'll add my text field, which also will hold a string. And then I'll export this to-do class. And we're now getting some errors here regarding ID and text. And we're seeing that the property text has no initializer and is not definitely assigned in the constructor. What this warning is telling us is that I'm defining a class here, which is meant to be instantiated. That's the main idea behind classes in general. But that those properties which I set up and describe in there, where I set the types, never receive a value. And we can make sure that they do receive a value by adding a constructor. This constructor could then also want some arguments. And here I want to get the to-do text as an argument, because I'll generate the ID dynamically in the constructor then. And the to-do text will also be of type string, hence the type annotation here. So now we got type annotations on the properties, and then here also on the constructor on the argument. And inside of the constructor, I'll then set this text equal to to-do text. To-do text here. And I'll set this ID equal to an ID which I want to generate here. And I'll just use a date here and convert this to a string. That's not a perfect unique ID, but it's good enough. So now whenever we create a new to-do, this ID gets created automatically. And now we have this to-do object definition, this class definition here in this TypeScript file. And that's very close to how this would look like in just JavaScript. In just JavaScript, we would basically not have these two property descriptions, and we would just have this code, which would work in just JavaScript. But in TypeScript, when using TypeScript, you also have to define those properties ahead of time to make it clear which types of values will be stored in there. And with that, we can now use this to-do class. And we can use it in app.tsx, for example, to create some dummy to-dos. Here we can have our to-dos, and that is an array. And in that array, I want to now instantiate my to-dos based on this to-do class. For this, I'll import to-do from /models to-do. Again, you can omit the file extension here. And then we instantiate and create those objects based on the to-do class, just as we do it in vanilla JavaScript. We can use new to-do here twice to create two to-dos. And then we need to pass in that to-do text, like learn React and learn Typescript. And now our to-dos, this here is no longer an array of strings, but instead an array of to-do objects. Now I want to pass that as a value for the items prop into to-dos, and to accept this array of to-do objects instead of array of strings, we have to change the type annotation here in the to-dos component. Because there I currently want an array of strings. Now, the great thing is that if you are defining a class, this class also acts not just as a constructor function, which you can call to create new objects, but also as a type. You can use your class name as a type. And therefore, in the to-dos component, I can import to-do from going up one level, diving into models, to-do, and we can make it clear that items will be an array of to-dos based on that to-do class, which means items will be an array full of objects that fulfill the description, the definition of this to-do class. So full of objects that have an ID property, which is of type string, and a text property, which is of type string. Or to be precise, objects created with this class as a constructor function. That's what we now want as an array here for this items prop. And that, of course, also means that if we map through the items, we no longer want to set the key equal to this object, but instead probably to item.id and the text equal to item.text. And with this now, we updated to-dos TSX. Now in app.tsx, we just need to use our to-dos array as a value for this items prop. So here I'll now pass to-dos as a value to the items prop to the to-dos component. And if we do that, again, the visual output does not change, but our code definitely changed. And please note that with all those type annotations and all those classes we're using here, we are making it very clear which shape our data should have, which shape our components should have, and that simply allows us as a developer to ensure that this code is clean, that it has a clear structure, and that it's way harder to misuse our components or our data, and that errors can be prevented during development instead of at runtime when we test the app. Because if we pass in incorrect to-dos here, we get a warning right in the editor instead of an error, which we would then get at some point in the running app. And that's the benefit of TypeScript. So lots of TypeScript concepts are already at work here. And as mentioned before, if you want to learn about all those concepts in depth, you definitely want to check out the official TypeScript docs or some other TypeScript resources. For example, of course, also my complete TypeScript course, which I have. But now let's dig a bit deeper here. We got this basic to-dos component here, which outputs these to-do items here. Now, very often for that, we would now have a separate to-do component, so that this list item here is in a separate to-do component, because in reality, it often might be more complex than just a li opening and closing tag and some text in between, even though that is what we have here. Now, I got a challenge and a little practice for you at this point. I want you to outsource this into a separate component And you should keep the JSX code as it is. Don't make that more complex, but make sure you create a new component and configure it correctly regarding the type it needs, the types it receives, the type of component it is. Make sure you do that such that you can continue working with that array of to-dos. Here's a short pause for you to pause the video and try this on your own. Thereafter, we're going to implement this together. Were you successful? Let's build this together. And for this, I'll create a new component, the todo.tsx file or the todoitem.tsx file. And I'll go with todo-item so that we have no confusion or clash with the to-do class we have here. Now in this todo-item component file here, I want to create my todo-item functional components, and I'll write it as an arrow function here, and then export this, this todo-item here, todo-item like this. Now here we'll get this props object, we know that already, because we'll ultimately return a list item with props.text as a content. The key will not be added here because the key should be added directly in the list, so where you call map, and therefore I will add the key once we use the todo-item component here in the to-dos component. But the key is not our primary problem at this point. Instead, the problem which we got here is that we have those red squiggly lines because props is implicitly of type any. And it is implicitly of type any because we have no type annotations here. Now, when you create a new functional component, you learned that you should add this React FC type annotation. And that's what I'll do here. I'll make it clear that todo-item is a React functional component by adding this type annotation. And for this, we can import React, though we don't even have to do that in modern React project setups. You can still add the React import if you want to, but you don't have to. So now we make it clear that this is a functional component. But now I get an error here because we now use a text property which doesn't exist. Because out of the box, a component gets props, but it only has this children prop, maybe. And it definitely does not have a text prop out of the box. That's why we need those angle brackets here. That allows us to merge in our own prop definitions with those base props. And here we now want to set up an object type, because props is always an object, and we always merge an object with those base props. And we now want to make it clear which kind of prop we can expect here. And here it's now really up to you. You could expect the entire to-do as a prop, so the full to-do item, including the ID, so an object based on this model. But that is actually redundant here, because in this component we're not using the ID. We're only using the text. And therefore we maybe just want to get this text or the to-do text, however you want to name it. I'll go with text here, which will be a string, because that's all we need here. And if I set it up like this error is gone, and this component is ready to be used. If you came up with a solution where instead you expect to get the entire to-do, and you import to-do from your models folder, that's also fine. But here I'll just build a very minimal component and just expect the text. And now we can go to to-dos tsx, and here I'll now import todo-item from this todo-item tsx file. And here I'll output todo-item for every item in this to-dos, in this items prop here. And I'll set this key. We can set this even though we're not expecting a key prop here in our todo-item component, because we are using this FC base type. that does not just give us the children prop here, it also actually makes sure that we can add these special props like the key prop on our component when we're using it. So we can add the key prop here to to-do item, this key attribute, so to say, and set this to item.id. And now, very important, add the text prop. And I'm also getting auto-completion here. If I press Control space, you see that this text prop is wanted. It's suggested here. And then here I'll set this equal to item.text. And that's one way of building this to-do item component and using TypeScript for it. And with that, if I save everything again, we still get the same output as we did throughout the entire module. So that's not too exciting. But now we're using yet another component, which again embraces TypeScript. And I'm really emphasizing this because this is the bread and butter of using React with TypeScript. Now that we built a lot of components that dealt with outputting to-dos, let's make sure our actual to-dos no longer have to be hard-coded dummy to-dos, but that we instead let the user enter new to-dos. And for this, I'll add yet another component here, the new to-do component, which should display a form that handles user input where we get the, to-dos a user added. For this here, I'll again create a functional component by using const and then the arrow function syntax. And I'll export this new to-do component here, new to-do, like this. And here, I now want to return my form. I want to render a form that allows the user to enter a new to-do. Now, this will be a very simple form which I built here. I want to have a label where I say to-do text. Below that, an input of type text where the user should enter the concrete to-do. And below that, a button for adding that to-do, for submitting that form. That's the JSX code I want here. We can refine the styling a little bit later. For the moment, let's just add it like this, and let's focus just on React and TypeScript. Now on that label, I'll add the HTML4 attribute, so to say, this prop here to point at the text input, which is this one here. So I added ID text here to connect the label to it for accessibility. But now with that, that's the finished JSX code. And what I want to do now is I want to handle the form submission and prevent the browser default, as we learned it in this course. And in addition, I want to, of course, then get the user input. And for getting the user input, we, of course, learned about two main approaches. We can either listen to every keystroke with use state, or we use a ref to then get the user input once the form is submitted. And it depends on what you want to do, if you want to validate with every keystroke or not, which approach you want to use. And here I'll go for the ref approach because we're going to see use state in action later anyways. Now let's start with the form submission function. For this, I'll add a new function in this component function. And that will be the submit handler function, though the name is up to you. In there, I expect an event argument so that I can call event prevent default, but we can already see that I'm not getting any auto-completion and that we got red squiggly lines here. Now we're getting red squiggly lines because TypeScript has no idea which type of data this event thing will be. We as a developer know that it will actually be such an event object, which is emitted and passed automatically when we connect this function to the appropriate event listener, but that's not something TypeScript can know. So we have to add a type annotation here. And here, since we'll add this function to the submit event through React, so with help of React, with help of React's onSubmit property later, since we'll do that, the type here will be the React.form event. and you can actually omit this import as you learned. That's a special type provided by the React package in the end, which is this event object type, which will get automatically when listening to the form submission. There also is a mouse event, for example, which you would get if you add an on-click listener. That's then the event object you get, but for the form submission, it's the form event. And then here we can call prevent default. You now see I get auto-completion because now I'm clearly describing which type of data we'll get here. Now we can connect this here and pass the submit handler to onSubmit. By the way, if I would be using mouse event here, you see I'm now getting an error down there with a very long message, basically telling me that the type of function I'm pointing at here for onSubmit is not the type of function React is expecting. Because for the onSubmit prop, React is expecting a pointer at a function that actually gets an argument of type form event, not of type mouse event. So that's an extra little check which we get here, which is great. And now with that turned back to form event, everything is working again. Now we want to extract the entered input, and we'll do that with help of refs here. Now we learned how we can use refs in a functional component. We can import the use ref hook here from React. And once we did that, we can create a ref, like the to-do text input ref here, for example. And we call useRef like this to create such a reference. Then we can go to the HTML element to which we want to connect the ref, typically an input element or a text area or something like this. And we set the special ref property on that element and point at our ref. In this case, we point at to-do text input ref. Now, if I do that, you see I get an error down there though. Again, with a very long text, that in the end, ref is receiving the wrong type of data. Now, ref wants a ref created with useRef. That's not wrong, but we're not explicit enough about the ref we're creating here. In vanilla JavaScript, this code works because we don't have the concept of extra type annotations. But when working with TypeScript, TypeScript actually wants to know a bit more about our ref. When we create it here, TypeScript actually has no idea that we eventually will connect it to an input element. That's only clear down there. But since it's not clear in this line, we could use this ref in any possible way. We can connect it to any HTML element. And that's in the end the kind of error we get here. We're passing a ref as a ref to this input that is not clearly focused on this kind of HTML element. This could also be a ref that wants a button. So we have to be more explicit about the kind of data we will store in this ref eventually. And we do this again with a generic type. That's why useRef actually is a generic type out of the box. We can add the angle brackets here now to explicitly set the concrete type of ref we want to create in this instance. So useRef, is able to work with all kinds of data we will store in this ref here, all kinds of HTML objects we could connect with this ref, but we now have to specify which concrete value or HTML element we plan on storing into this specific ref object we are creating here. And here I know that I want to store such an input element, and that has a built-in type, and that's the HTML input element type. All those DOM elements have built-in types which you can use in TypeScript to refer to them, and for the input it's the HTML input element, for a button it would be the HTML button element, for a paragraph it would be the HTML paragraph element, and so on. You can also always visit the MDN page of an element, like here the input element. And even though that of course is not focusing on TypeScript at all, on that page, you will find information like this. Like here, you find that the input element is based on the HTML input element interface. And that's why we use that as a type here. So now we are making it clear that the ref we're creating here will actually be connected to an HTML input element. But I'm still getting an error down there. And we're getting this error because actually we have to set a default value here, because this ref could already be assigned to some other element maybe, out of the box by default. And that's why we should provide a starting value here. And at the beginning, we have no connection, and therefore the starting value is null. But once we add this error goes away, because now we are creating a ref, which will eventually be connected to an HTML input element, but which has no initial value. And we have to be explicit about this in case of use ref. And that's how you then create a ref when using TypeScript, and how you then connect it to an element. And that then again just works as you learned it. Now inside of the submit handler, we can of course get the entered text by referring to the to-do text input ref .current. That's how we always do it for refs. They always have this current property, which then holds the actual value. And now the great thing is that since we explicitly set this ref to hold an input element, an HTML input element, we get great autocompletion here. And we get all those input element object properties as suggestions here. So all the properties input element objects can have in JavaScript. And hence we, for example, also get this value auto-suggestion. You will notice this question mark after current though, which in my case was added automatically by the IDE. Where is this coming from? This question mark was added automatically by my IDE here because the ref is not necessarily set to a value yet when we use it. Of course, here, as a developer, we know that when the submit handler is called, to-do text input ref will be connected to an element, because this function can only be called when this form was submitted, and that form can only be submitted after this ref was connected. But of course, theoretically, I could also try to extract a value right here after defining this ref, and in that case, the ref would not be connected yet. And TypeScript doesn't deeply analyze our code. It doesn't know that this technically can't be called before this connection is established. In that case, this question mark addition here signals to TypeScript that it tries to access value, and if that succeeds, the entered value will be stored in entered text. But if that fails, if the connection should not be established yet, null will be stored in entered text. And that's why here the inferred type of entered text actually also is string or undefined, which is basically the same as null here. So that means that TypeScript doesn't necessarily know that it will be able to extract this value. Now, if you as a developer are sure though that at this point of time there will be a non-null value, so here in this case you know that the connection has been established, you can use an exclamation mark instead of a question mark. This special annotation tells TypeScript that you know that this possibly nullish value will never be null in this spot. And therefore, of course, you should only use this annotation if you are 100% sure that this can't be null. So in this case, that this connection will have been established. And then the inferred type here is just string, not string or undefined, because you are sure that the connection will always be established and that extracting the value will therefore always succeed. And we can definitely do that here, since we know that technically submit handler, the way we write our code, can't be called before this line of code was parsed and this connection was therefore established. But that is an important concept which I definitely also wanted to briefly explore here. Now, it is worth pointing out, though, that these question mark and exclamation mark operators are not related to refs specifically. This is also not a React specific feature. Instead, these are regular operators which you can use in TypeScript when you are working with values that could be null. With question mark, you're always saying, try to get me that value, and if it's null, store null in the constant or wherever I want to store that value. With the exclamation mark, you're saying, I'm certain that here we won't be dealing with null, so therefore drill into this object, into this property, and give me the actual stored non-null value. And therefore then you will always get that value. But of course, as explained, that only works if you are certain that this can't be null. So these are two generally important operators in TypeScript, which here are very important when working with refs, since refs could be null or could not be connected to any value at this point. And with that, we now got the entered text, and we could now validate it and check if entered text, once we trim it, maybe is empty, which would mean that nothing was entered in the end, just a bunch of blanks, or anything like that. So here we could throw an error. I'll just return though. If we make it past this if check, we know that we have a valid input. And just to make this clear, this is not about whether the ref is connected or not. This is just validating the text entered by the user, which has nothing to do with TypeScript. But once we made it past this if check, we now want to add that to-do to our list of to-dos. And we probably don't do this here inside of our new to-do component function. Instead, we're managing the list of to-dos in the app component, and hence we'll need a way of communicating back to this app component to add the new to-do there. And we're going to do that in the next lecture. So with the new to-do component added, let's go to the app component. And there I actually want to use this new to-do component. So here I added the import, and now I'm using new to-do here in the JSX code. And of course, the to-dos array here should now be managed with help of this new to-do component. Whenever a new to-do is added there, it should be added to this array here, so that this array is not hard-coded but dynamic. For this, we got a couple of steps we need to take. We need to use state to manage this array with state, so that this app component will re-render when this array changes, so that the to-dos component updates when it changes. And we need a way of communicating back from new to-do into this app component. And that's what I want to start with. For this, in the new to-do component, here in the submit handler, I actually want to call a function which will be stored in app component. And that's of course a pattern we used a lot in this course. We learned that we can pass pointers at functions as props to our components. And that's exactly what I need here. In new to do, I want to get my props object. And then here in the submit handler, I want to call props on add to do, for example, expecting that on add to do is getting a function as a value so that I can execute it as a function. And then to on add to do, I want to pass my entered text, so my string here, which I extract from the to do text input ref. That's how I want to write this. But we now get an error up here. And that's of course an error we had many times before already. I actually never clarified that new to do will be a functional component. And we should absolutely do that. I should add react.fc here to make that clear. And then, if we need our own custom props, as we do here, I should embrace that generic nature of this fc type to define my concrete prop object definition of my own props, which I want to add in here, that will be merged with the base props. And here I want to make it clear that this new to-do component will actually get a onAddToDo prop, which will be of type what? Well, which will actually be a function. And for this, we can define a so-called function type in TypeScript. And that is actually quite straightforward to do. For this, you can add an arrow function here, but just as curly braces in this spot would not create an object, using this arrow function syntax here does not create an arrow function. Instead, we're here in a part where we want a type definition, and this is TypeScript's syntax for defining the shape of a function. So for describing a function type. And here we know that onAddToDo should be of type function, so here I'm describing how this function should look like. And between the brackets, we would describe the parameters this function will get, and after the arrow, we describe the return type of this function. Now here, onAddToDo shouldn't return anything, because when we call this function, we're not doing anything with the return value. We're not storing it in a constant, we're not outputting it, so we don't need a return value here. Hence, we can set void as an expected return value of this function we get as a value on onAddToDo. But onAddToDo should be a function that gets an argument, a parameter, because I'm passing an argument down there when I'm calling this function. And currently we're saying that onAddToDo is a function that gets no parameters. That's my function type definition up there at the moment. That's why we're getting the red squiggly lines down there. This onAddToDo function currently expects 0 arguments, but it gets 1, entered text in this case. And of course it should get 1, so we need to update this function type definition up there. We should get an argument here, which we can give any name we want. In this case, I'll just use text, which should be of type string. And now all the errors are gone, because now I'm making it clear that onAddToDo will be a function, and that's a function that returns nothing but takes one parameter, which is of type string. So now calling it the function like this works. If I would set this to type number, it of course fails because entered text is a string and not a number. But that's okay because here we want a string. So let's switch this back. Well, and now with that, just as all the times before, in the place where we use new to do, so in the app component, we now have to make sure that we pass in this prop which we're expecting. So onAddToDo should now be added as a prop here, and the value for that should now be such a function that has this shape. Now that's a function which we now have to define here in app.tsx. So here I'll add a new constant and I'll name it addToDoHandler, and that's now an arrow function, let's say. And that arrow function needs a specific shape. Now that's a concrete function definition here now, not a type definition, because here we got some regular JavaScript code in the end. Now the shape of this function is that it shouldn't return anything, so not having a return statement here is fine, but it should accept a parameter. It should get the actual to-do text or just text, you can name it however you want, which, and that's important now, should be of type string, because that is the function shape we are expecting in the new to-do component. So if we want to pass this function through the onAddToDo to new to-do, we have to make sure that this shape is correct. And here it is correct, so now we can pass a pointer at addToDoHandler to new to-do. And now it's in addToDoHandler where we want to manipulate this to-dos array. So this state managed array, as it soon will be. So it's time for use state, because of course we need to manage this to-dos array with state so that when we change it, this component re-renders and therefore this to-dos items also re-renders and is updated. And for this, of course, we do what we learned in this course. We import use state from React like this. And then to-dos actually will be converted. I will get rid of those dummy to-dos here. And instead, I will call use state here. And we now don't just get back to-dos here, but we get back an array, as you learned, which we can destructure, where we get our to-dos and this state updating function. And thanks to TypeScript, we now, for example, see that set to-dos, if we hover over it, is actually of type React dispatch, which might not be 100% clear, but which is actually that state updating function which we can call to change our state, to dispatch a state update, so to say. Now, use state, of course, can take an initial value, and that could be an array, an empty array initially, because initially we have no to-dos. But here we actually now introduced a subtle problem if we write it like this. And do you see which problem that is? The problem is that I'm just passing in an empty array as a default value here. But TypeScript is not able to infer which types of values should be accepted in that array eventually. That's why to-dos at the moment is of type never array, which basically means it always must be an empty array. No values are allowed in there. That's what this strange never type means here. And that's of course not what we want. But TypeScript infers this type because it's not able to infer that this should be an array of to-dos, for example, eventually, because the initial value has no information about that. To make it clear that we initially have an empty array, but that eventually we want to have an array full of to-do items here, we again need to tell TypeScript somehow. And we can tell TypeScript because use state, this use state function, out of the box is a generic function. It is generic for exactly this reason, so that we can set the type of data we eventually want to store in this state. So we add angle brackets again, and now we want to make it clear that the kind of data managed by this state will be an array of to-dos. We do this by using our to-do type from that models folder, and then square brackets. That means that this state will manage an array of to-dos. Initially, it's an empty array, because that's also fine. That does not conflict with this type definition. But if we do add items to this array eventually, they have to be to-do items, not strings, not numbers, to-do items, which have the shape of the to-do object class here we created here. And now that's the proper way of defining this state. Now in add to-do handler, we then want to create our new to-do by calling new to-do and passing in the to-do text as a value to the constructor. And then we want to call set to-dos and update our state. Now here I want to use my old to-dos state, so the existing array, and add this new to-do. And you learned that if you want to update your state based on the previous state, you should use this function form of updating your state. And in this function, you get the current state, so to say, or the previous state, depending on how you want to look at it. And then you need to return your updated state here. So in this case, I'll return previous to-dos, concat new to-do. Concat is a method which we can call that will create a new array, which we should do. We should not mutate the existing array. We should return a new array here, which then will be used as a new state by React. And this new array, thanks to concat, contains this new to-do. That's how we can properly update this state here. And with all that in place, if we now save this and I reload, I got this unstyled form here and no to-do list at the moment. But if I then enter learn React here, then this is added. And if I add learn TypeScript, this also is added. So that is working. Now let's continue, and first of all, I want to add some styling. For this, I prepared three .module.css files, which you find attached. The to-dos module CSS, the to-do item, and the new to-do .module CSS files. And we will simply add them like we did it before in this course. There is nothing TypeScript specific about adding CSS files to your component files, no matter if you use global CSS or CSS modules. Here I am CSS modules, hence the naming of these CSS files. Since we are in a project created by Create React App, we got that built-in CSS modules support. And here we can now import the classes, for example, from todos.module.css. So just as we did it without TypeScript. And then here on this unordered list, we can add the list class. That's, the todos class. That's the class I defined in that todos module CSS file. And we'll do the same in the other files as well. In the to-do item TSX file, we can import classes from /todoitem.module.css, and then we add class name.classes.item to this list item. .item, because in this todoitem.module CSS file, I have this item CSS class. And in the new to-do TSX file, we also import classes from ./new-to-do.module.css, and with that imported, we can go to the form and on it add class name classes.form. And if you do all of that and save everything, you should have that look here on your screen, where you can learn React and then learn TypeScript, and that works just like that. And that's now the same app as before, just with some styling. Now, adding to-dos is great. I also want to make sure that we can remove to-dos by simply clicking on them. And that's again another challenge I got for you. Add the code to this little demo app that ensures that if we click on a to-do, we remove that to-do. You will only need things you learned up to this point. After a couple of seconds, which you can take to pause the video to try it on your own, we will do that together. So, were you successful? Let's now make sure we can remove to-dos. For that, I want to go to the to-do item and make sure that we can click that. And when we click it, we remove a to-do. For that, on this list item here, our to-do item, I want to add the onClick prop, this built-in onClick prop, to trigger some code when that is clicked. And then here, in the end, I want to point at a function which I expect to get through props, because that is how we typically do this and how we did that up to this point in the course in most demos. So therefore here, upon a click, I want to trigger some function which is received through props, and hence here we could, for example, expect a prop named onRemoveToDo. The name is up to you because it's your component. But of course I'm getting some red squiggly lines here. And why am I getting this? Because I'm using a prop here, I'm referring to a prop which I'm not describing here in my type definition for this functional component. Here I'm clearly just saying that this component function will receive a props object which has these base props, the children prop, and then my own props here merged into that. But there, I only have a text prop, nothing else. No onRemoveToDo prop. Now, since I want to accept such an onRemoveToDo prop, we should also describe it here. So we should make it clear that we will get a onRemoveToDo prop here as well, and then set the type of that prop value. And here that should be a function which I'm binding to onClick. So therefore, we can describe a function type here. We are not interested in the return value, so here that can be void, so the function doesn't return anything. And regarding the argument, the parameter, we actually also don't need one. Now, in case of onClick, so since we're passing this function on to onClick, we could actually expect an event argument here, which would be of type React mouse event. That would be a type we could set here. This would describe the kind of function we can pass to onClick accurately. But actually, describing this argument type is optional, because we might not be using it here, and therefore, thankfully, we can also omit it and just shorten this function definition to just this definition. So now we're passing this function, which we receive on onRemoveToDo, which has this shape, to onClick. Now we need to go to the place where we use ToDoItem and make sure that this prop with such a kind of value is set. And that's the todos.tsx file, of course. Here we're currently only passing in the text prop, and we should now also pass in the onRemoveToDo prop. And thankfully, because we use TypeScript here, we get this auto-completion again. So now we want to set onRemoveToDo to such a function which we're expecting. Now in the todos component, I actually don't want to define that function though, because the todos are being managed in app.tsx. So here again, I just in the end want to forward some prop value which I get in this component. So we're building such a prop chain. So therefore here we can also accept another prop in this todos component, which is maybe also called onRemoveToDo, but that name is up to you, but which then also will be a function that has no parameters and that then actually also doesn't return anything. And here we then pass props.onRemoveToDo as a value to the onRemoveToDo prop of ToDoItem. And that's again all just what we learned in this course about passing functions to different components and about building these prop chains for forwarding props through multiple layers of components. And then here in app.tsx, ultimately, we have to add onRemoveToDo here on todos as well. And now here I want to define the function that should eventually be called. The removeToDo handler function, which has a function that looks like this, no arguments and doesn't return anything. And now it's this removeToDo handler, which we pass as a value to onRemoveToDo. But this function definition is actually not correct. How would we know which to-do to remove? In the end here, I need some identification criteria. And for to-dos, since every to-do has a unique ID, getting that ID would make a lot of sense. So in app.tsx, this removeToDo handler should actually get the ID of the to-do that has to be removed. This to-do ID, which will be of type string. It will be of type string because that's the type we use for our IDs in this to-dos object. And then when we got that, we can actually call setTodos and use this function form, since we're updating the state based on the previous state. And then there we could return privTodos filter to filter out the to-do which we want to remove, and go through all the to-dos and remove the to-do where the ID is equal to to-do ID, and not filter out the other to-dos. That's how we can do that. So that's how we can remove a to-do from this list of to-dos, and how we remove the to-do with that ID which we're getting here. We are checking for inequality here because we want to keep all the to-dos where the IDs do not match, and that's the way we have to look at this. But we now have a problem. removeToDo handler now wants this to-do ID of type string. But that's not the type of function onRemoveToDo is giving us here. In this todos component, after all, I said that the function we get here takes no parameters. And that's simply incorrect. Indeed, here we should expect that ID, which is of type string. But now on remove to do on the to do item is having the wrong definition, because there I'm still saying that we have no parameters. And again, that's simply incorrect here. And we can now either update that here and make sure that we do set the correct ID here, though for that we also need to accept it here as a prop. Or we go to todo's TSX and we actually bind on remove to do. Bind is a default method in JavaScript which allows us to pre-configure a function for future execution. We also saw that a couple of times in this course. And here we first of all set what the this keyword will refer to in this to be called function. And we don't care about that here, so I'll set that to null. And then we set the first argument on remove to do will then receive later. And that should be that ID here, so item.id. And with that, all the errors are cleared, because now on remove to do will indeed receive that ID here when it's being called. And that then allows us to properly remove a to do. If we now save everything, if I click on a to do, it is removed. So if I add all my to dos here, I can delete them by clicking on them. And that's now working, as we see in the console, also without any errors or warnings. And that's how we can use React with TypeScript. Now, to finish this module, this introductory module here, I also want to show you how you can use the context API with TypeScript. And then we'll wrap this up and I'll show you which other resources you can check out to learn more about React and TypeScript. So let's now wrap up this module by also exploring the context API with TypeScript. For this, I'll add a new folder, store, which is not a must-have, but the convention we used typically in this course. And there I'll add my todo-context.tsx file. A TSX because I'll write some JSX code in there. Now in there we can start by creating the to-dos context by calling React create context. And for this, even though it's technically not required, it's not a bad idea to import React to make it a bit more transparent where React is coming from here. Now I'm calling create context here, and create context actually wants a default value. It wants one argument. And here that can be an object where we describe the shape of this to-dos context. And there we'll have our items, let's say, which will initially be an empty array. And then we also have the add to do function, which will be a function that does nothing here, and the remove to do function, which gets the ID of type string and then does nothing. Now at this point already, we can add more TypeScript logic. Because, for example, items is an empty array here, and we again would have the problem that it's not clear which kind of values should eventually end up in this array. For that reason, create context also is a generic type, so we can add those angle brackets here after create context in front of the parameter list to better describe our context object. Because here, between the brackets, we're not setting up some type definition. This here is some concrete JavaScript code where we create a JavaScript object with some properties. So here we're not setting up some type. The only type we're setting up here is this argument type because I'm creating a concrete function here. To define the overall type of this object here, we need to use this generic type feature between the angle brackets and then describe our context object type here. And here we can now make it clear that items will now be a to-do array. For that, we import to-do from the models folder and the to-do file there. And now here we have a pure type definition. So here I'm making it clear that items will be of type to-do array. And then I'm making it clear that add to-do will be a function type that returns nothing. So that's the difference to down there. That's a concrete function definition with an empty function body. That's a function type definition where I'm just defining the return type of that function here, void, and no parameters. And then remove to do which is also a function that returns nothing but that gets an argument of type string. And that's now my to-dos context. Now I'll create such a context provider component, as I also did it multiple times in this course, which will be responsible for managing that context state. So here I'll add the to-dos context provider component here. And that will be a functional component, so we should set this to react.fc as a type to make it clear that we'll store a functional component in there. Therefore, we need to return some renderable content here, because that makes up a functional component. And hence here I'll return some JSX code. To be precise, I'll return to-dos context.provider. And then between that, I want to output props children. And children is a default prop, so we don't need to describe this shape of props for that. Like this. Now, of course, here in the to-dos context provider, I want to manage my state for this context. So therefore, in there, we want to call useState. And for that, make sure you import useState from React. And manage the to-dos state here as we did it in app.tsx before. And therefore, I'll actually copy or cut all that code from the app component, this state management code and the functions there, and add that here into this to-dos context provider component like this. Because that code is still valid and still fine to be used like this. And now that I added this here, we can construct our context value here, which is an object of that shape here. So of these types and values. And therefore here I can add my items and set this equal to to-dos, which is this to-dos state I'm getting here. And I set add to-do equal to add to-do handler, and remove to-do equal to remove to-do handler. And now I can set the value here equal to context value. And if I do that, I get red squiggly lines here. I'm getting red squiggly lines because actually my context value object here does not have exactly the shape I describe up here when I create my context. Now what's the difference? The difference is add to do, and I introduced this on purpose. I define here, when I create my context, that add to do does not take any parameters. But clearly it takes a parameter when I then create the concrete function for this object. Here I'm expecting the to-do text. And then I'm setting this add to do handler function as a value for add to do. That's why I'm getting this error down here. Now I'm getting this error down here because here, when I create this context value object, I'm not saying anything about the type of data that's expected in this context value object. We might want to do that to already catch the error here though. And for that, we can add a type assignment here as well to be clear about the type we want to have in there instead of inferring it. That's a scenario where setting the type explicitly could make sense so that we're not inferring a type that's incorrect as we're currently doing it. And the type I want to set here is of course the same type as up there. So I can copy that and add that down there. Now we see that we catch the error here already. Now before we fix it though, copy and pasting is always not ideal. So instead of copy and pasting this type definition, I'd rather set up this type definition only once to then use it in all the places where we need it. And to implement that feature, we can of course create such a type alias again. We can create our to-dos context object here, for example. This name is up to you. And store this type definition in this type alias. Now we can use this alias here between the angle brackets and use that same type down there to avoid this copy and pasting. So here I'll now also use this alias. And now we also of course should fix this error. And we fixed this error by updating our type definition, which we now, because we're not copy and pasting, only have to do in one place. And here, add to do is actually a function that should get some text instead of no parameters. So that's an important fix. And with that, we're setting up the correct context value, and we're setting this as a value for this value prop on this provider component then. Now we're setting up this to-dos context provider. Hence, we can now export this here, export this as a default maybe, and also export the context itself, not the type definition, but the context, because we'll need that for the use context hook later. And actually, not later, but now. Now I want to connect my created context here to the different components. And for this, first of all, we don't need to manage to-dos in the app.tsx file anymore. Here we can get rid of on-add to-do on the new to-do component, and we can get rid of these props here on the to-dos component. We can get rid of the to-do import from the models folder and of the use state import. This app component can be way leaner now. Because now in those components, we can use the context. For example, in the to-dos component. Here, we can now import use context from React and also import our to-dos context actually as a named import between curly braces from going up one level store to-dos context. And I'm importing the context here, not the provider, so that I can tap into that context here. So that we can call use context as we learned it in this course and tap into this to-dos context here. And that will give us access to the to-dos context like this. And if you hover over this constant, you now see that it automatically knows the type of value that's managed by our context, thanks to TypeScript and us linking everything correctly. And now here we can use to-dos context to go through all to-dos context.items, which are my to-dos now. And instead of props on remove to-do, I now want to call to-dos context remove to-do. And I'll still call bind though, because I still want to pre-configure this function to get the right ID eventually. Now, of course, we can get rid of the props argument here, and therefore we should also get rid of our own props type definition here on React FC. Because this to-dos component doesn't use props anymore. Instead, it now uses context. So we should simplify that and remove that unnecessary type definition. That, of course, also means that we can get rid of that to-do type import from the models folder. That's now the cleaned up to-dos component using the context API. Now we also, of course, want to use the context API in the new to-do component. There we add a to-do, and now we also don't want to leverage props anymore for that, since we're not using the parent component for managing to-dos anymore, but we want to use context. So from React, we import use context, and then here I'll import to-dos context from going up one level, store to-dos context. And just as in the other component, and just as in this entire course, we now call use context and point at to-dos context, and that gives us our to-dos context. And with that, here, instead of calling props on add to-do, I now call to-dos context add to-do and pass in my entered text. And that's the change we need to make here. The rest of this component internal code stays the way it is. Now, what does not stay the way it is the component definition though. We don't get props anymore, so we should remove that parameter, and therefore we should also remove that prop description here for this functional component, because we don't have any special props anymore. Hence, we should remove that here and clean up that component. And now there's only one missing thing, and that's the usage of our to-dos context provider component. because using use context is fine, but it only works if we somehow wrap these components that use the context with that context provider. And we can do that in the app.tsx file, and for example, replace that div with the to-dos context provider, which you need to import from store to-dos context. That's super important. Without that, it would not work. But with that, if you add this, I can again learn React and TypeScript and more. And I can, of course, also still remove things without any errors in the console here. So that is working. And that's how we can use the context API with React and TypeScript. Now that's it for this module. We learned a lot about React and TypeScript here. It was quite an in-depth module with lots of examples and concepts. But of course, we're only scratching the surface of TypeScript in general here. And of course, we kind of went through that entire content rather quickly, because this is just a summary of TypeScript and React. If you want to learn more about that, for React, you got this entire course, and for TypeScript, I got a couple of resources that could be useful. If you search for TypeScript Lang, or actually also just for TypeScript, you find the official docs. And those are, of course, a great place to learn more about TypeScript. There you can dive into the docs or the handbook, and you learn about all those core TypeScript features, and you also find examples there. And that site, therefore, is really a good resource for learning all about TypeScript in the greatest detail possible. But it can also be overwhelming. Now, for React and TypeScript, if you search for Create React App in TypeScript, you find that setup article from before again, and in there you also find more resources on getting started with TypeScript and React. You get an example project, for example, a cheat sheet, and a link to the official docs. Now, I also got a TypeScript course which you could check out as an alternative. This course does not focus on React and TypeScript, but just TypeScript. And of course, taking it is optional. You get all the knowledge you need also with those free resources. But if you want to learn all about TypeScript from me in this course, that course could be very helpful. It also does have another React and TypeScript introductory section, but the core content and focus of that course is just TypeScript, and we're going to dive into all the key features there. And these are possible next steps which you could take to build up on the knowledge you gained in this module to build React apps with TypeScript if you prefer that over just JavaScript with React. Now, as a bonus in this module, I want to have another look at this tsconfig JSON file, since I promised that, and since it is important to at least understand the basics about this file. This is a file which you can add to any project where you are using TypeScript, so where you are compiling TypeScript code to JavaScript code, and then this will configure this compilation. Now, speaking of the compilation, in this React and TypeScript project, the compiler is invoked automatically when we start the development server or when we build this project for production. We are using a behind-the-scenes build workflow setup where this TypeScript compiler is integrated. So here we configure this compiler, and in there you got various options. To understand all those options, of course, check out those official docs or my course. I do dive into greater detail there, and the official docs also explain all those options. But you can also hover over an option, and you will get at least a short description here and a link for the more detailed explanation. So that's very helpful. This links to the official docs. And I'll also walk you through the most important options here. And that starts with the target. This in the end controls the target JavaScript version to which your code will be transformed. And in this case, that's ES5 JavaScript, which is quite an old version, but which of course means that you should generally have a broad browser support. Though I will say that depending on your project setup, this target option might not be the only thing that influences the output. There also can be project setups where your TypeScript code might be compiled to JavaScript, and then you might have yet another compilation step, for example, with other tools like Babel, that take that output JavaScript code and transform it even more. So that's not necessarily the last step in line, but it often will be. And that then simply controls to which kind of JavaScript code your TypeScript code is transformed. Now here we see some default TypeScript libraries that are included, and that influences which kind of types are known out of the box by our TypeScript code. And these are some libraries which are actually built into TypeScript, so we don't need to install some extra packages here, but to unlock them in this project, we still need to list them here. Now, the DOM lib, which is added here, for example, ensures that some default DOM types are understood by TypeScript. And a great example here can be found in the new to-do TSX file. This HTML input element type. I mentioned that this is a built-in type, and it's actually such a built-in type that's unlocked because we have that DOM lib added here. If I would remove DOM here from lib and save this, then eventually here you see I'm getting an error down there. That value does not exist on this type because it actually doesn't fully understand this type then. So that's an important lib which we should have here. So in here, I'll bring back DOM. Now, for those other settings, allow JS controls that we could also include just .js files, so plain JavaScript files in our projects, and import from such a plain JavaScript file without causing an error. If we want to mix and match TypeScript and JavaScript files, that's possible with this option. Then we get a couple of options which are not that important for us here. Very important though is the strict option. This is set to true, which means that we have the strictest possible settings for this project. And that, for example, influences that we can't have implicitly any values, as we had it with parameters in the past. If we had a parameter somewhere where we didn't set the type, for example, if I remove the type here, then we get those squiggly lines that it implicitly has the any type. And with strict mode, that's not allowed. We have to explicitly set a type in places where TypeScript is not able to infer it. Strict true also unlocks a couple of other strict features, but this non-implicit any type feature is the most important one for us here. Now then we got more options which are not that important for us here. The JSX option is interesting. It basically controls that JSX code is supported and which output code should be generated. And in general, the default settings which we got here, of course, should work, and you should only change them if you know what you're doing. But you can configure TypeScript's behavior here, and you now have a rough understanding of what this file does. Again, you can always dive into the official docs to learn more about those different settings.